In this playlist, I'm going over every algebra question on the SAT. This is part 13. It's systems of two linear equations in two variables. This is a continuation of part 12, where I'm going over all of the hard questions. Any questions that you don't find in this video, look in the previous one, and you can find those exact question IDs. All of the questions I'm going to go over in this video are 3 out of 3 difficulty. If you look them up on the SAT online question bank on the College Board website, all of them are in the domain algebra, and as I said, the skill is systems of two linear equations in two variables. Just think of that as systems of linear equations. As with every video, the question IDs will be up here in the top left for each question. If you look in the video description, you'll be able to see all of those question IDs listed along with the timestamp of when I start going over that problem and a brief description of the topic of the problem. So I'm going to start with these two questions, which are the most recently added systems questions. They added these since I started the series. So I'm going to have to actually go back and add some to previous videos. But we have these two, and then I believe there are about another 19 or 20 that I didn't finish in the first video. So which system of linear equations has no solution? We know that for a system of linear equations to have no solution, it means that there are going to be two parallel lines. So two lines with the same slope but different y-intercepts, because parallel lines will never get closer, never get further apart. They are never going to cross, which means there's no point of intersection, and that would mean no solution. So we want to find which of these are parallel lines. Now, one option is you get a Desmos calculator on the test for every question. So you could just type all of these equations into Desmos, see which one produces parallel lines. That set will be your correct answer. But we can also go through them. You could get them into slope-intercept form. So that'd be y equals mx plus b form. And then just compare those slopes and those y-intercepts. Again, if they have the same slope but also the same y-intercept, then they're not going to have no solution. They have infinitely many solutions, because that would mean that they're literally just going to be the same line, basically graphed on top of itself. So any point on that line is a solution to both equations. So if we look at this, we've got negative 2x plus 3y equals negative 9, and 2x minus 3y equals 9. Just looking at the top equation and the bottom equation are equivalent, except you're just multiplying the left side and the right side by negative 1. Right, so think about if we multiply every single term by negative 1, or some people even think of that as dividing it by negative 1, it's the same thing. Right? It turns negatives into positives, positives into negatives. So the negative 2x becomes positive 2x, the positive 3y becomes negative 3y, the negative 9 becomes positive 9. Since we did the same thing to both sides, we didn't actually change anything about the equation. Like, these are still equivalent equations, which means that these, if you graph them, will be the same line. So we know it's not going to be A. Next, we have 2x minus 3y equals 9, and 3x plus 4y equals 10. So you could, again, put them into slope-intercept form. You could remember that if you have it in standard form, that's ax plus by equals c form for a line, then your slope, to get the slope, you have to get the y term alone, right, to get it into slope-intercept form. So you subtract ax from both sides and then divide everything by this coefficient in front of the y, the b. So your slope ends up being negative a over b. Because again, you're moving this over here and then dividing by b. So you can think of that's where it's coming from. But essentially what that means is whatever your terms are on the left side, whatever those coefficients are, would need to be either the same exact numbers or numbers that when you divide them, right, have the same proportions to each other. So in this case, right, negative a over b for this first equation in b would be negative 2 over negative 3, which gives you positive 2/3. The negatives cancel out. And for the second one, we'd have negative 3 over negative positive 4, which is just 4. So 2/3 and negative 3/4 are different, which means they're going to have different slopes. So the fact that these have different slopes mean they will cross, they will have one solution, because they're just two lines with different slopes. For option C here, we have 2x minus 3y equals 9, and negative 6x plus 9y equals negative 27. So in this case, this is why I made sure not to say they need to have the same exact coefficients. But in this case, they don't have the same coefficients, but they are the same proportion. Right? So if we do negative a over b, it would be negative 2 over, the b is negative 3. So negative 2 over negative 3 is positive 2/3. The negatives will cancel out. And then here we have negative 6, right? A negative of a negative is positive. So I could write it like that. Over the b value is just positive 9. So negative of a negative makes positive 6 over 9, which you can simplify to 2/3. So both of these equations have the same slope, 2/3, even though they have different coefficients in front of the x and the y respectively, are going to have the same slope, right? If you got it into slope-intercept form, the it would be y equals 2/3 x plus, and then your y-intercept. So the main thing that you have to compare here is if these y-intercepts would be the same. Now, again, if you want to use standard form, to get this into slope-intercept form, you would have to divide the c by b, right? Because first you're moving the ax over there, and then you have to get rid of that coefficient in front of y. So divide by b, and that means that your y-intercept is going to be equal to c over b, right? Your c term over your b term. That would be, for this first equation, 9 is your c term, over your b term is -3. So c over -3 gives you -3 for your y-intercept. And then for the other one, we have -27 is your c term. If you divide that by your b term of 9, -27 over 9 is also -3. So these are, again, the same line graphed twice. If you want to think of it the same way that I did for that first problem, just think, okay, what would I have to multiply these numbers by to get them to be what they are in the second equation? So like what would you have to multiply 2 by to get -6? We have to multiply that by -3. Same thing with -3, you have to multiply that by -3 to get +9. So if you multiply both terms on the left side by -3, or like think of it as the entire left side is being multiplied by -3, you need to multiply that entire right side by -3 to keep it balanced, to make it the same equation. -3 times 2x is -6x, -3y times -3 is +9, 9 times -3 is -27. So again, this is just the same equation rewritten, except you multiplied every term by -3, which would still appear the same way on a graph. So again, this will be the same equation graphed twice. So this will have infinite solutions. So if we're writing down what we have so far, the first equation, infinite solutions, that's the same line in two different forms, like written in two different ways. The second option will have one solution, right? The two different lines, two different slopes, so they're going to cross at one point. And then C is again the same line graphed twice. So even without figuring out that D does have the same slope and that D does have two different y-intercepts, if we did these first three steps right, through the process of elimination, we'll know that D is going to be correct. But I always would recommend that you still check, just in case one of your previous eliminations had some flawed math in it, right? So just verify that D is in fact going to be two parallel lines. So first, let's verify the slopes. If we want to do what we just did, we'd think, okay, what do you have to multiply -2 by to get +4? That'd be -2. So if you multiply every term by -2, what does that give us? It'd be -2 times -2 is +4x, right? That matches. +3 times -2 is -6y. Okay, that also matches. So the left side is the same. It's equivalent if you just multiply everything by -2. And then +9 times -2 would give you -18. So just by that c value being different, our c value is not going to be our y-intercept, but we can see that this c value is -18. The one that's in the second equation is +18. So just by virtue of them being different, you know the y-intercepts will be different. Now, if you want to actually find the two different y-intercepts, you'd say, all right, well, for this first equation, c over b would be 9 over 3. So that means that your y-intercept would be equal to 9 over 3 is 3. And for the second equation, your c value is 18. So we get 18 over our b value is -6. 18 over -6 is -3. So one of them crosses the y-axis at 0, 3. One of them is at 0, -3, which means that even though they have the same slope, and again, we can verify that slope by doing -a over b. So the first equation, that would be -2 over 3. The negatives will cancel out, which gives us 2/3. And then for the second equation, we'd get -4 over -6. That's your b value. Again, the negatives will cancel. 4 divided by 6 is the same as 2 divided by 3. So those both have a slope of 2/3, right? Same slope, but two different y-intercepts, so they will never cross. D will be your answer. So again, that's how you would do that algebraically without using your graphing calculator. You're also more than welcome to just graph all of these, or even after you find D to verify it, you could type those equations into a graphing calculator. So I'm using here the test mode version. You can get just normal Desmos while you're practicing, or they even have a test mode version. You just go to College Board, and it'll be the one that you'll have on the SAT as well as any AP exams. And now we just type in our equations. The first one, we have -2x plus 3y equals +9. And the second equation was 4x minus 6y is equal to +18. So you can see, as we said, one of them has a y-intercept of 3, one of them has a y-intercept of -3. They very clearly appear to be parallel lines. If you zoom out, they're not getting any closer or further apart from each other. Like the zoom makes them appear closer, but you can see they're staying that same distance apart. They're 6 apart at any x value. So those are parallel lines. They will have no solution. All right, this second one that they added here, we've got two equations, negative x minus wy, so w is your coefficient there, you could think of it as negative w, I guess, equals negative 337, and 2x minus wy equals 47. In the given system of equations, w is a constant. In the xy plane, the graphs of these equations intersect at the point q, comma 19, where q is a constant. What is the value of w? So we need to make sure that they are not parallel, for one, and then we also need to make sure that they cross at a y value of 19. They don't actually need us to figure out what the x value of the intersection point is. Like, it doesn't matter. Q can be any constant, but we'll probably end up doing that. We'll see how it goes. But so we have negative x minus wy equals negative 337, and 2x minus wy equals 47. So for whatever value, let's actually plug in this point, q comma 19. So the x will be the q, the 19 will be the y, and we get negative q minus w times 19 is equal to negative 337. And we get 2 times q, or 2q, minus w times, again, 19 equals 47. So we need this to work. It doesn't, again, matter what q is for this problem. We just need to figure out what w is. And essentially, we have given ourselves a system of equations now. System of equations with two variables. Instead of x and y, we have w and q. So we're just going to be solving for w. So if we want to solve for w, think of it, we basically want to get rid of the q's. Now we could solve for q, like get q alone on one side and then plug that in for the value of q. That will work. You could also put it in your graphing calculator, just make sure you keep track of what's q and what's w. But what I'm going to do is just elimination. So we see we have a 2q in the second equation. We have a negative q, so like think of it as a negative 1q in the first equation. So we can just multiply every term in this first equation by positive 2. So on the left side and the right side, that gives us negative 2q minus 2w times 19, which, I mean, we could simplify that, but and then negative 337 times 2 would give us negative 674. All right, so we got this. Let's distribute. So w times 19 gives us 19w, and then 2w times 19 will give us 38w. Both of those are negative. We got a negative sign up front. So now if we combine these two equations, right, add the left sides together, add the right sides together, right, they're supposed to be equivalent on both sides, so it's like adding the same thing to both sides. We get 2q plus negative 2q is 0. Those cancel out. Negative 19w plus negative 38w would give us negative 57w. And that would be equal to 47 minus 674, which would be negative 627. Think of basically 674 minus 47. Like that's how much you have to take away from it to get it down to 0. And then you have another 627 to go below 0. So we've got negative 57w equals negative 627. So now we can just divide both sides by this coefficient from the w. So divide both sides by negative 57. The negatives will cancel. 57s cancel over here. I'm just going to type this in my calculator. 627 divided by 57 gives us 11. So w equals 11. And we don't need to know what q is. We just needed to solve for w. What value of w will make this work? Again, if you wanted to find q, you just plug w back into one of these equations, and you can find it that way. The other way you could check it, and this is what I would recommend if you do have time to check and you want to make sure you're 100% correct on this problem, right? If you knew how to do it, you just want to make sure you don't lose the points because you messed up the math somewhere or messed up some easy algebra step. So we can just type these equations in. So we have negative x minus wy, and again, our w value we said is 11. So that's going to be negative x minus 11y equals negative 337. That's one equation. Now, if we plug w into this second equation, we get 2x minus 11y equals 47. All right, so those are our two equations. Now, if I go back to Desmos, I can type those in. So let's shrink down a little bit. We had negative x minus, again, it was wy, so we're making it 11y because we found w to be 11. And that should be equal to negative 337. And then for the second equation, we have 2x, and again, it was minus wy, so I'm going to make it minus 11y. So 11, again, is our value of w, and that should be equal to 47, positive 47. So if we look at these, we want them to cross at some point that is a y value of 19. We look here, 128, comma 19. So that means 128 is our value of Q. Again, they didn't need that, but that's just a quick way to find it. I would recommend doing it this way if you want to check, right? Even if you don't feel like just typing equations in. Now, some of these hard questions, you can't just straight type them into the calculator, like some of the easy and medium systems questions. And you know, that might be the fastest way, most time efficient way to solve some of those easier systems questions. But for these ones, what the calculator will be really useful for is checking some of your answers, especially if it's one of these conceptual questions using constants and where you have to figure out what the constant is. This calculator tool could be really helpful for verifying, especially if you're strong in math, you want to make sure you don't make a single error so you can get that 800 on the SAT. So that is how you do those two questions. Those are the two newest system questions they've added. I think they added both of them within the last month. But now we'll look at the rest of the set from earlier. So again, if you watch part 12, you'll be able to see all of these questions. I think I went over about 20 questions. And now I can start on the next set, which is question ID 7866A908. So again, you can find these all in the video description. If you've done a systems question, you're trying to find it and it's not showing up in here, just look in the previous video. It's probably in that description. All right, but let's dive in here. We've got a sample of a certain alloy, has a total mass of 50 grams and is 50% silicon by mass. The sample was created by combining two pieces of different alloys. The first piece was 30% silicon by mass, and the second piece was 80% silicon by mass. What was the mass in grams of silicon in the second piece? So we can see just by looking at it, you go, okay, well, 30 and 80, the average of those would be like halfway between them. So they're 50 apart, which means you'd have to add 25, right, half of 50 to get to the average. So it would be 55% silicon by mass if it was equal parts of both combined. Right? You can think of it that way. Like it would end up being the average of the two, but it's less than that. It's only 50% silicon by mass, not 55. So that tells us that it's going to be more of the 30% silicon than the 80%, right? Because the 30% is what's bringing the average down, the 80% is what's bringing the average up. So that just gives us an indication. If it's a 50 gram alloy, right? Again, if it was 55%, that would mean it was 25 grams of the first type, the 30%, and 25 grams of the second type. But because it's less than 55, we know this is going to be greater than 25 grams of the first part and less than 25 grams of the second part. So that immediately helps us eliminate one of these answers, because this is what is the mass in grams of the silicon of the second piece. So they're asking how much of this 80% by mass, and since we know that that amount has to be less than 25, right, because it's the average is below 55, we can cross off D. Doesn't really help us beyond there, right? We don't know if it's A, B, or C. I would guess it's probably going to be close to 25. So, you know, if you were, say you were doing this problem, you had like 30 seconds left, you don't think you're going to be able to type it in time, you go, okay, well, it's not going to be A, because 50% is not that far off of 55. So it shouldn't be bringing it down that much. But again, I'm not going to do that officially, because hopefully you get to this question with enough time. So it is systems of equations. So we want to add this up, and we could go, all right, let's call this maybe F for it's the first type, and this will be S for second. Although always be careful with S's, they sometimes look like fives. So maybe I'll do T for 30, right? This one's the 30% by mass, and E for 80, okay? So you could do X and Y, you can do whatever you want. Even S is fine, just again, always be careful if you use S's. Sometimes, especially if you write fives like me, the fives and S's can look similar when you're looking back at it later. So we know that T plus E, if those are the number of grams of the 30% silicon by mass and the number of grams of the 80% by mass that were combined, they have to add up to this total mass of 50 grams. Law of conservation of matter, it can't be going up or going down when you combine those two things. All right, so T plus E equals 50. Now, if you multiply T by 0.3, so 0.3 T, and you add that with 0.8 E, that'd be the total mass of silicon, because we've got the mass of this times what percent of that, 30%, which is 0.3, is silicon, and then this is the mass of that. So we know that that is going to be the total mass of silicon. So there's two ways you could do this now. You could divide this by the grams, then make it equal to 50, right? So you could go like, okay, this divided by 50 grams is equal to 50%, 0.5. Right, that would work because, right, this numerator that I just wrote, this is the mass of silicon from the first part plus the mass of silicon from the second part, adds up to the total mass of silicon in the alloy, the combined sample. And then if you divide that by the total mass of the sample, it should give you that half of it, right, like they said, is silicon. So you could write it like this, or if you want, you could just go, okay, well, if the left side is the total mass of silicon, we know that the total mass of silicon is going to be half of the 50-gram sample. So you just write 0.5 times 50 on the right side. Right, so we have the total mass of silicon in the alloy on the left side and the total mass of the silicon in the alloy on the right side. Right, so they're two equal values. Now you could also see, like, if you just did do the original way, it was just divided by 50 and this is 0.5 over there, the way you would, you could get to the same thing by multiplying both sides by 50 anyway. But there's also a logical reason for why it would look like this. So I'm just going to set it up like this, okay? So now we've got our two equations. And, you do get your calculator on every question. So we could solve this algebraically. I'm going to show you how to do it algebraically pretty quickly. And then from there, I will move on and show you how you could do it with the calculator. Because, again, especially if you're in a rush and you're really comfortable using Desmos, it is a great tool that you're given. In this question, what they consider to be the hardest part is what we just did. It's writing your two equations accurately and then setting it up, knowing that you're going to be able to interpret that to find your answer. Again, we're trying to find what E is. So if you just type these in and graph them, just keep track of what variable you're putting as E, and then whatever the E value is of the point where they cross, that's going to be your answer. But if we want to do it algebraically, we want to solve for E, we have to get rid of our T's. So what we could do is multiply everything in this first equation by 0.3, or actually by negative 0.3, because we have a positive one already. So times negative 0.3 times negative 0.3 times negative 0.3, and that gives us negative 0.3t minus 0.3e is equal to 0.3 times 50 would be 15. All right? So, and I'll just simplify this. 0.5 times 50 is 25. So in the alloy, you have 25, was it grams? 25 grams of silicon. And that should be negative. Be very careful of that. I almost messed it up. Negative 0.3 times 50 gives us negative 15. Right? The whole reason that I do the negatives is so I wouldn't forget something like that, but almost just did. So now I just combine the left side and the left side, combine the right side and the right side, and we get 0.3t plus negative 0.3t is 0. Those cancel out. That's the whole point of this. And then we have 0.8e plus negative 0.3. We get 0.8e plus negative 0.3e, think of it as 0.8e minus 0.3e, that gives us 0.5e, and then 25 plus negative 15 is 10. So we get 0.5 times e equals 10. Now you can think what times a half is 10, so e is going to be 20, or just multiply both sides by 2, right? 0.5 is the same as 0.5, or divide it by 0.5 is the same thing. We get that e is equal to 20. So our E value is 20. You could check it algebraically by plugging that 20 back in for your E. You'd find that T is equal to 30. So you have 30 grams of T, 20 grams of E. Again, that does make logical sense. There should be more T than there is E to bring the average below the middle of those two, the middle of 30 and 80. From there, then you could plug in, okay, well, if we know that T is 30 and E is 20, you could plug them into this second equation and see if it does, in fact, give you the 25. Or, again, if you want to check it, what I think is probably faster is to just type your equations into Desmos. We have 0.3t, and I'm going to type the t as an x, but just make sure you keep track of t as x, right? You could also do that one as y, it doesn't really matter. Just make sure you keep track of what it is. Plus 0.8 y, again, y is going to be my e value, and that's equal to, we could write 25, or you could do 50 times 0.5, or you don't need to simplify it on here. And then for the other equation, it was just t plus e equals 50, so I'm going to write x plus y equals 50. And then if we look where those two cross, it's right here, 30 comma 20. As we said, the e value is the y value, right? Or that's what I typed it in as. If you want to do the opposite, just make sure you keep track. So we're looking for our e value, which is our y value, that's 20. Right? It's the same thing we got when we did it algebraically. You can see that this is quite a bit faster if you know how to type it in. But there is the one possible mistake that you're adding in that you could potentially write 30 instead of 20 or mess it up like that. But just take your time, even if you're doing it the Desmos way, trying to take a shortcut, make sure that you're being very systematic. Okay, so as we said, the answer is 20. This is a multiple choice question, so we'll circle C, that's 20. It was very likely to not be 9 because that would just mean it would be, 9 and 41. It's way more of the 30%, so it should be much closer to 30 if that was the case. But this was a good way to verify it is 20, not the option B, which is 16. So here, I think this is supposed to be a system of equations. In the given system of equations, R is a constant. Okay, so let's figure out where these are supposed to, one of them is supposed to end and the other one's supposed to start. Again, hopefully on the real test, they figured out how to format this so it's not confusing. It does kind of look like it's just like this is equal to this is equal to this, right? It's like one equation with two different equal signs. But I would guess based on the fact that, so you have an equals here, 30y, and then because there's a plus before that 24, they wouldn't just start a different equation with a plus. But because the only thing in front of the equal sign is the ry, I think that it's supposed to end the 24, and then the next one is ry equals 1/6 minus 16x, right? So I guess this kind of makes sense. They have y's on both sides of the equation, which I guess if you want to get it into standard form, you're going to have to move those y's over for the first equation. For the second equation, it's basically in slope-intercept form, except that you've got that coefficient r, which is a constant, in front of the y. So to get it into slope-intercept form, you'd have to divide everything by r. All right, but let's see. If the system has no solution, what is the value of r? Okay, well, we've talked about this in previous problems now, but for a system of linear equations to have no solution, you need to have two parallel lines. So two lines with the same slope. So we could say like M1 is equivalent to M2, but they have two different y-intercepts. So B1, and by B, I don't mean B in terms of standard form, like AX plus BY equals C. I mean B in terms of Y equals MX plus B. So B1 would be different, so it's not equal to B2. So the two lines would have the same slope, but two different y-intercepts. All right, so this first equation, we have 48x minus 72y equals 30y plus 24. So this one, I'm just gonna get this into standard form because it's pretty close to that. You just subtract 30y from both sides. It gives us 48x minus 102y equals 24. So from here, if you wanna find the slope and the y-intercept, you could do, okay, well, our slope would be equal to negative a over b. Our y-intercept would be equal to c over b, which means negative a is negative 48 over b is negative 102. You do it like that, and then c over b would be 24 over negative 102, like that. Or we could also just get it into slope-intercept form, get the y alone. So I'd subtract 48x from both sides. I don't think that takes that much longer, and then it's a little bit easier to just look at it. We get negative 102y equals negative 48x plus 24. And then I would divide everything by negative 102, which gives us y is equal to, 102 is a multiple of 6. So we can do 48 divided by 6 is 8. And then 102 divided by 6 is 17. So it's 8 over 17x. And you have a negative divided by negative, so it's going to give you a positive. So 8/17 x. So it means our slope is what you're multiplying x by, 8/17. And then 24 is also a multiple of 6. So we could do 24 divided by 6 is 4. And, this should be minus actually because we have a positive divided by a negative. 102 divided by 6, as we said, is 17. All right, so we get y equals 8/17 x minus 4 over 17. So our y-intercept is negative 4 over 17. So you just need to have a different one for your other equation, right, the one with the r in it. So now for our second equation, we have ry is equal to 1/6 minus 16x. I'll just rearrange this so we have the negative 16x front. It's the commutative property of addition. Doesn't matter what order you add those two things. And then plus 1/6 at the end. And now again, to get it into slope-intercept form, I'm just going to divide everything by r, because r over r is 1. So instead of ry, we'll get 1y, or just y, is equal to negative 16 over r times x plus 1 over 6r. Right? 1/6 divided by r is 1 over 6r. So now, just following those rules we said before, our two slopes have to be the same. So 8 over 17 is our slope for this first equation. Has to be equal to, and then the slope for the second one is going to be the coefficient in front of the x when it's in slope-intercept form. So that's negative 16 over r. So 8 over 17 equals negative 16 over r. That's one of the stipulations you need. And the other one is just the y-intercepts have to be different. So basically 1 over 6r, this second y-intercept, is not equivalent to negative 4 over 17. I don't think that will be an issue. So let's focus on this first equation where they are equal to figure out what the actual value of r has to be. And then we just check it to make sure that it does have two different values. Okay, so we could get the r alone by cross multiplying. We get 8r equals 17 times negative 16. And then to get r alone, we divide both sides by 8. And now I've got r equals, well, negative 16 divided by 8. That's going to be negative 2. Right? 16 divided by 8 is 2. So we get 17 times negative 2, which is negative 34. And just checking that, negative 16 over negative 34, the negatives would cancel out, so it would give you a positive value. And right, that's just like 8 times 2 is 16, 17 times 2 is 34, so that checks out. So our value would be negative 34, and then again, just to verify that it does have two different y-intercepts, you could also graph them and see if they do intersect, or they should show up as parallel lines. Plug in this negative 34 for r, so we get 1 over 6 times negative 34, and that just has to be not equal to negative 4 over 17. Okay, 6 times negative 34 would be 204, so it'd be negative 1 over 204 is not equal to 4 over 17, or negative 4 over 17. Those are not equivalent fractions, right? They're both fully simplified there. So that checks out, right? Followed both rules to be two lines that don't intersect, the same slope, two different y-intercepts. All right, so they ask, what is the value of r? We said r had to be negative 34 right here. So that would be what you would enter in as your answer, negative 34. All right, here we have another system of equations. This one is a little bit nicer because clearly, like, this is not how you would write 486x. So you can see that that's where those two are separated. We have 24x plus y equals 48 for one equation, and 6x plus y equals 72 for the other equation. The solution to the given system of equations is x comma y. What is the value of y? So we're just trying to find the y value. Now, to find the y value, you would want to get rid of your x's. So I'm going to use elimination, which is a big shocker. I know I tend to prefer elimination when it's, I think a lot of times it does save time unless they give you one of the variables already isolated. In this case, we have y for the first equation, we have y for the second equation. If you were just solving for x comma y, then you would probably start by multiplying one of the equations by negative 1, like every term, just get rid of the y, you could solve for x. Since we're trying to solve for y, I'm going to show you how you would just go straight to solving for the y, which means eliminating the x values. Because on every problem on here, I'm going over how to check your answers as well. I think that's an important skill. In case you have the time to do it, you can really verify, before you submit your test or that section of the test, that you got every single systems question correct. But if you don't have time, you want to make sure that you're knowing how to go pinpoint right to the answer. Just be deliberate to not make mistakes with your math the first time, and that should work out for you. All right, so here we have 24x, positive 24x in the first equation, and the second equation we have positive 6x. So I'm going to multiply that second equation by negative 4. So instead of 6 times x, we'll have negative 24x, which will cancel out the 24x in the first equation. So if I multiply this term by negative 4, I have to multiply every term by negative 4 on the left and the right side. I know my 4s look a little like 9s, but that will give us negative 24x minus 4y equals negative 288. All right, so that's your second equation. The first equation they gave us, I'm just going to leave it as is, 24x plus y equals positive 48. All right, so now if I combine the left sides of these equations and the right sides, and right, it's equivalent values on both sides of the equal sign, so you're adding the same thing, essentially, it really is the same thing to both sides of the equation, so it's staying balanced. And we get negative 24x plus positive 24x cancels, that's 0. Negative 4y plus positive y would give you negative 3y, right? You're making it closer to 0 when you're adding a smaller positive number to a bigger negative number. Same thing here, negative 288 plus 48, you're bringing it closer to 0. So you think like this 8 will bring it to negative 280, and then adding 40 to negative 280 will give you negative 240. Right, so we get negative 3y equals negative 240. And then to solve for y, you just divide both sides by negative 3. Negatives cancel on both sides. 3's cancel, you get y is equal to 240 divided by 3 will be 80, which just think 3 times 8 is 24. So y is equal to 80. And I think it's a short answer question. So, and if you're pressed for time, you should feel confident you did your math correctly. You could just enter in 80. Maybe start the question, say, if I have time, I can check this very quickly. So, and to check it, you just type those equations both into Desmos, or you could have done this from the start, but 24x plus y equals 48, and 6x plus y equals 72. 24x plus y equals 48, and 6x plus y equals 72. So these two equations, they cross at this point, and it is negative 1.3 repeating, comma 80. And we're solving for the y value, which we found to be 80. Desmos will also give you that same answer. Right? The y value is 80. So that's one way to check it. You could also plug in the y for one of those equations, solve for the x value, and then plug both your x and your y into the other equation, see if they work out. Right, but again, those are just ways to check it. You don't need to do that to do the problem. This is the only math that you would need to do if you're doing it algebraically, or you could go straight into that graphical approach. And if you could type them in quickly, it might even be faster. A movie theater sells two types of tickets: adult tickets for $12 and child tickets for $8. If the theater sold 30 tickets for a total of $300, how much in dollars was spent on adult tickets? So we're trying to solve for the adult tickets. Let's call the number of adult tickets A, and the number of child tickets, we'll call that C. So we have to write our system equations. So write two different answers. It says discard the dollar sign when gridding your answer. Okay, yeah, there's not even, I don't think, a way to do that. But we would say, first of all, the total tickets is 30, right? They add up to 30 tickets. So if A is the number of adult tickets and C is the number of child tickets, if we add those two together, those are the only two types of tickets. They didn't say anything about senior citizen tickets or anything. They specifically say they sell two types of tickets. That will add up to all the tickets, so that adds up to 30. That's one equation, A plus C equals 30. The next equation we'll have to do with the total cost. So $300 is the total revenue that they generated, and they'd get $12 per adult ticket, so that'd be 12 times the number of adult tickets, or 12A, it's the money from the adult tickets, plus child tickets are 8 each, so 8 times C. So 12A plus 8C equals 300. All right, so these are two equations, and these are two perfectly good equations. But the one thing I'll warn you, it says how much in dollars was spent on adult tickets. So we're not solving for A. Again, A is the number of adult tickets. You could even have set this equation up so that you do solve for one of the variables in it, but just note, we're solving for 12A. So 12A is what we want to find ultimately. We'll start by finding what A is, and then you'd have to multiply that by 12. Now, I'll show you how, if you wanted to set it up so that there's no risk of forgetting that, you would just go, okay, well, X is the money from the adult tickets and Y is the money from the child tickets. So when we add that up, it's $300. And then if you want to find the number of tickets, you'd be dividing, right? So if you made X dollars and each adult ticket was 12, then X divided by 12 is the number of adult tickets. And right, Y is the money made from child tickets. You divide that by the price per child ticket to get the number of child tickets. So Y divided by 8 would be equal to 30. So you could set it up this way, and then you're just solving for X. I think that it doesn't necessarily overcomplicate it, but then you're adding equation with fractional coefficients, which some people are prone to make errors on. So you're adding in an extra complication just to make sure you don't forget to multiply by 12. I think just always on the SAT, spend the extra time to reread that last sentence or the last part of the sentence. What exactly are they looking for? Because especially when you get to these hard questions, sometimes the math you're actually doing is not that much harder than the medium questions, but they just add in some little trick they're trying to catch you on. So always just be like, okay, be mindful, like almost be vigilant to a point where you expect them to be trying to trick you and almost make a game out of it of, can I figure out what this trick is? It will make the test a little bit more fun to take as well, if you think of it that way. It's like a little game between the test maker and you. They're going to try to trick you. Can you figure out what it is? All right, so just looking at these, we've got A plus C equals 30, 12A plus 8C equals 300. To solve for A, which again, A is not going to be our answer, 12A is going to be our answer, but if to first find what A is to figure that out, we will get rid of our C's. So to do that, I'm going to multiply every term in the top equation by -8. We could also just go straight to Desmos, but I like to do it algebraically first and then check it. Again, if you're really pressed for time and you're fast at using Desmos, that could be a good solution. But -8 times A is going to be -8A. And then we have -8C. And then -8 times 30 will give us -240. Now we just combine the left sides and combine the right sides. 12A plus -8A is 4A. The 8C and the -8C add up to 0, so they'll cancel out. And then 300 minus 240, or 300 plus -240, is positive 60. So we get 4 times A equals 60. Divide both sides by 4 to get A alone, or you can think what times 4 is 60. You probably think of that in terms of time. 4 sets of 15 minutes would be 60 or something like that. Not that this is time, it's just money. But we get A equals 15. That again is not our answer because our answer is going to be 12A. So we just have to do 12A is equal to 12 times 15, which means that 12A is equal to, that'd be 150 is 10 times 50. We do 10 times 15 plus 2 times 15 is 30, gives us 180. Or I guess you could rewrite it as 3 times 4 times 3 times 5, so it's 9 times 20, which is also 180. All right, so we get 180. That's the total revenue you made. Makes sense it's less than 300, but it's a little bit more than half, which makes sense because you're making more per ticket. And again, if you sold 15 adult tickets, that means half the tickets were adult tickets. The other half would be children's tickets. So it's 15 adult, 15 children tickets. So more of the money will come from the adults then by that same ratio of 12 to 8. So 180 is your answer. Again, they say do not bubble in or grid in a dollar sign, just write 180. Now again, if you want to check it on your calculator, you can. Just note, if you use these first two equations I wrote, then the point you're going to find is the 15, not the 180. So then you'd have to, from there, you could still do it on the calculator even, multiply that 15 by 12. So our equations are 6 plus 7r equals pw, and 7r minus 5w equals 5w plus 11. It says, in the given system of equations, p is a constant. If the system has no solution, what is the value of p? So for this system to have no solution, they seem to ask this a lot in the hard section, but for it to have no solution, that would mean that the two lines will be parallel lines. So there'll be two lines with the same slope, but two different y-intercepts. So they're never going to cross. So we can say m1 is equal to m2, and I'm going to say b1 is not equal to, so b1 meaning the y-intercept is not equal to b2, the y-intercept of the second equation. Usually with these ones where you're solving for the value of a constant, you mostly just have to focus on the slopes being the same, because there's only one value that you could put in for it usually to make the slopes be the same. And for there to be an answer, because they're not going to say, oh, there is no answer. That could be a thing that would show up on a math test in school, but for the SAT, right, you have to enter in your answer at some point. So this B1, B2 thing is just basically a way to check it, and something else you could check at the end. If you're in a rush, just prioritize the slope thing, because if you find the way to make the slopes the same, probably the y-intercepts will be different. If that's what they're looking for. So again, we could rewrite our equations. And now the interesting thing with this is they don't have x and y. So some people will be a little bit thrown off by that because they're used to, okay, I want to find the slope in terms of like change in y over change in x, or I want to get into slope intercept form, I have to know this. The other way you can do it is just set it up so that basically the left sides of the equation have both of the variables. So again, p is not a variable, it's a constant. So they have the r and the w on the left side of both equations, and then just a constant on the right side of the equation. And then you can use that to compare the two. If they are the same slope, then there should be a way to make it so the left sides look the same. I'll show you what I mean by that. So we have 6 plus 7r equals pw. So we want to get our r and w alone on the left side, our constant on the right side. We'll start by subtracting pw from both sides and subtracting 6 from both sides. So here, 6 minus 6, 0. We get 7r minus pw is equal to, and these cancel here, negative 6. Okay, so that's your first equation. Now for the second equation, we have 7r minus 5w equals 5w plus 11. We want to get our variables all together on the left side and just a constant on the right side. So we subtract 5w from both sides. Gets rid of this 5w over here. We get 7r minus 10w is equal to 11. All right, so those are our two equations. And they were really nice in that they gave us 7 as the coefficient for the r in both equations. So we don't really even need to manipulate the equations that much here. Like for instance, if they gave us 14r or negative 21r, then you'd have to multiply like every part of this by something. So if it was 14r, you'd have to multiply everything in the first equation by 2 to get them to both be 14r, or you could divide everything on this side by 2. But they have it already lined up like that. So we just need this entire left side to be the same as this entire left side, because that's going to be where your slope comes from. And we have negative p as our coefficient in front of w. Here we have negative 10 as our coefficient in front of w. So negative p has to be equal to negative 10 for this to work. And you just divide both of those by negative and would get that p is equal to 10. And then the fact that the right side, the negative 6 and the 11, are two different numbers when the left side of the equation is the same, tells us that they're going to be two different y-intercepts. So p is equal to 10. That would mean that when you rewrite this, it would be 6 plus 7r equals p again is 10, so 10w. I already would feel confident enough to just enter that answer in. But if you're afraid you might have messed up the algebra, or you might have made some like logical leap you're not allowed to, just check the equations. And I know they don't have x's and y's, but just make sure you change the variables to the same thing on both. So like if the r is going to be the x on the first equation, the r should also be the x on the second equation. All right, so we'll type them into Desmos as something like 6 plus 7x equals 10y. Right? You can see I changed the x to r, or the r to x, the w to y. You could have done the reverse as well. You could have made it 7y equals 10x. Just whatever you change them to, you have to change those same variables to the same things respectively. So again, we made r's into x's in this equation. So for the second equation, we have to do the same thing. So it would be, instead of 7r, it would be 7x minus 5. Again, instead of w, we could write y equals 5w plus 11. So 5y plus 11, like that. Right, so we've got those two equations. Now they got x's and y's. Just, again, make sure, maybe note somewhere, that r became x and that w became y, in case you have to go back to that. I put that p-value 10 in place of the coefficient on y. So now when I type these into Desmos, we get 6 plus 7x equals 10y. We have this line down here. And then for the second one, it's 7x minus 5y equals 5y plus 11. And you see, I don't even like make it in a neater form. I don't put the y's together or anything before I type it in, because you could mess that up, right? You could have messed that up when you're doing that on the paper. So type in it exactly how it was presented, except maybe you have to change the x's to y's, or you have to plug in your p-value, that p-value of 10, so that you actually have the numbers here. And we see we get two parallel lines. We know that parallel lines for linear systems will have no solutions. They never will cross. They're two lines of two different y-intercepts, the same slope. We zoom out. They're not getting closer or further apart the entire time. They're staying that same distance apart. Right, so that's a good way to verify it after you've done your work. Here we have 5x plus 14y equals 45, and 10x plus 7y equals 27. The solution to the given system of equations is x comma y. What is the value of x, y? So we're trying to find what is x times y. All right, so this one, we could solve it through elimination. You could do substitution. Again, I probably would not do substitution in this case. Or we could just go straight to Desmos. The only thing is, make sure that you note, what are they asking for? X, y, that means what's the value of x times y? So figure out what x is and y is. I guess, honestly, I think the fastest way to do this one is Desmos. In general, I'll say, well, elimination, maybe if you do it really quickly. And both of these are pretty doable to do with elimination, right? If you're trying to eliminate the x, you would multiply both sides by, or every term by -2, right? You get negative 10x in this first one. Or if you're trying to get rid of the y's, you do the same thing to the second equation, right? Multiply everything by -2. But then the only thing is, because we need to find what x is and what y is, we would ultimately need to then plug whichever one you solved back in, find the other one, and then multiply those two values together, which again is not too time consuming. You can very much do that, but I would recommend on this one definitely use Desmos, because you have that tool. And in this case, even if you're not the fastest person to type into Desmos, it'll be really quick, and you'll find what x and y are. You have to multiply them together. It doesn't even matter which one's x, which one's y. There's no like variables that you have to substitute in. So I'll just take these equations. First one is 5x plus 14y equals 45. And the second one, 10x plus 7y equals 27. Now we can see where they cross. It's this point right here. 0.6 comma 3. So our x value is 0.6. Our y value is 3. So make sure we typed those both in correctly. 0.6 times 3, that'd be 1.8. So 1.8. If you want to write it as a fraction, you could go, okay, well, this is 3/5 times 3. So it gives us 9/5. Okay, 9/5 is also an acceptable answer. Actually, you could have recognized this if you've done enough chemistry. When you're converting from Celsius to Fahrenheit, you have to multiply it by 9/5, and you might also multiply it by 1.8, because that's the equivalent value as a decimal. So, but anyway, that would be how you do that using Desmos. I guess I will go over how you could do it algebraically. I know some people are just very averse to using Desmos, and that's fine. But it's a bit tedious for this problem. So I really would recommend make sure that you can use Desmos. Don't necessarily get to a point where you rely on Desmos for every question, because just the act of doing it algebraically will a lot of times solidify these concepts to you. And sometimes it's better to do it. Like, you can easily mistype something. You might be more likely to mess up on a calculator for some questions than you would doing it by hand, especially if you've gotten the practice in. But make sure that you have all of those tools in your arsenal, and then you can choose which one you want to do. So again, for this one, we can multiply this first equation by -2 or the second equation by -2. Either one will work. That would give us negative 10x minus, I'm going to multiply the first equation, so that'd be -2, -2, -2. So we give it negative 10x minus 28y equals -90. The second equation we just leave as is, 10x plus 7y equals 27. If we combine these, the x's cancel out. We'd get negative 21y equals negative 63. Then divide both sides by negative 21. And it gives us that y is equal to, the negatives cancel here, y equals 3. So if y is 3, I mean, that's the same value that we got here, then you'd subsequently have to plug that value in to find y. Or you could do the other elimination if you really want. I had one student who thought when I said, oh, do elimination for this method, they thought you had to do elimination to find x and y. Like, no, just find elimination, find one of the variables using elimination. And then I guess it's technically substitution. I just think of it as plugging that value in. So I'll say, okay, well, if we have 10x plus 7y equals 27, we can say 10x plus 7, and our y value is 3. So 7 times 3 equals 27. So 10x plus 21 equals 27. Subtract 21 from both sides, we get 10x equals 6. So now to get x alone, you just divide both sides by 10. We get that x is equal to 6/10, which would be 3/5, or you could say x equals 0.6. Okay. Same thing that we had here. And then when you multiply those together, we get 3 times 3/5, again, would be 9/5, or 0.6 times 3, 1.8, same thing, right? Either of those answers is acceptable. It's either the same ones that we got by doing it through Desmos. And again, if you do that really quickly, if you're very comfortable doing elimination, your algebra skills are fast, this could potentially be faster. I mean, it took me a little bit just to go over, copy the equations down, type them into the thing, and then, and you do have to make sure that you're figuring out what is x, y. I do think that's one of the things that they'll get you with on Desmos. If you use Desmos for everything, you might be more prone to rushing and interpreting that incorrectly. So think about that previous question where we weren't solving for a, we were solving for a 12a. If you did it on Desmos, you might just go, okay, well, there's my a value, and then plug it in. That as your answer, you'd be wrong. Here, if you, gave the answer as x or just y, then you'd be wrong. But the nice thing with systems is a lot of times you're going to be checking anyway. What are they asking for? Are they asking for x comma y? Are they asking for x? Are they asking for y? So the fact that you have to check anyway, you're going to probably catch, oh, they're looking for x, y, whatever. All right, here we have a system, and they actually space this one nicely. So we have in the system of equations above, c is a constant. If the system has no solution, what is the value of c? Okay, they love these no solution ones for the hard section here. We know, as I've said, with all of these no solution ones, that means that these two lines have to be parallel. So they have the same slope, but different y-intercepts. Now, this one's actually pretty nice because they gave it to us in slope-intercept form already. So we could just go, okay, well, our slope for this first one is 1/2. So m1 equals 1/2. And our y-intercept for the first one is 8. They gave us the y-intercept for the second one is 10. So these are already two different y-intercepts. That checks out. So we could say b1 is not equal to b2. That works. So we need to find what value of c will meet the second criterion, which is that the slope of the first line is the same as the slope of the second line. Okay, so the same slope, two different y-intercepts. So again, if the slope of the first one they gave us was 1/2, c is just going to be the slope of the second one because it's the coefficient in front of the x when it's in slope-intercept form. So m2 equals c. We just need 1/2 to be equal to c. And there's no math we even have to do here. It's just 1/2 is c. So 1/2 will be our answer here. And when that is the case, then they will have the same slopes, different y-intercepts. It will meet both criteria that we need. So we'll have no solution to parallel lines. Here we have another system that they did not separate well, but it looks like it's ending at this 25 because they don't usually do mixed numbers, just randomly an equation like that as a coefficient. So this one ends at the 25, the next one starts at the 5/2. We have 7/2 x plus 6y equals 25 and 5/2 x plus 6y equals 23. The solution to the given system of equations is x comma y. What is the value of, okay, this is interesting, 17/2 x plus 18y? So what I'm guessing with this one is there's a way that you can solve it without even figuring out what x and y are. And just looking closely, we want to get it to be 18y, and we have a 6y and a 6y. So we're going to double one of the equations. And we want it to be 17/2. We have 7/2 here already, and then 5/2. Double 5/2 is 10/2. So 7/2 plus 10/2 would give us that 17/2 x's. And then, again, doubling is what we want to do for the y's as well, and could be for either equation. So I'm going to double the right side of I'm going to double the right equation, the second equation, and you have to double the left and the right side of the equation every term, which means that our first equation we'll keep as 7/2 x plus 6y equals 25. Our second equation, when you double it, 5/2 times 2 is going to be 10/2 x plus 2 times 6y is 12y equals 2 times 23 would be 46. Right, so those are our two equations. Now we just add the left sides together, add the right sides. This is technically not elimination because we're not eliminating anything. We're just basically manipulating it to get this thing that we want. And then 7 halves x plus 10 halves x is 17 halves x. They have the same denominator, so you can just add the numerators of the coefficients. And then 6y plus 12y gives us 18y. And 25 plus 46 will be 71. Right, so 17 halves x plus 18y, which is, again, what we're solving for, is equal to 71. So 71 is our answer. All right, so that is definitely how you should do it. That's what they're looking for you to do. That's the fastest way to do this one. If you want, you could type those both into Desmos, calculate x, calculate y, or it would just be the point of intersection, and then plug your x back in, plug your y back in. But this is an example of how just being able to do it algebraically will help you recognize, oh, like there's some way I can manipulate this to get this weird answer. If they're giving you something really, if they're asking for something really weird, there's probably a way to find it. Like even when they ask for what's x plus y, there might be a way to find it. But sometimes they'll just do that as like a little trick, and there's not an easy way to get it to be x plus y. And it's not too hard to solve for x, solve for y, add them up. If they're doing something like this, don't be necessarily suspicious. Although they're trying to make this one really hard, think there's probably a much faster way to do this than just the most straightforward way. So think about how can I manipulate it to get it like this, and you get 71. Again, if you do it the other way, it's fine. Just make sure that you're being really efficient with your time in the other problems as well. In the system of equations above, a is a constant. So a is a constant. If the system of equations has no solution, again, what is the value of a? Okay, well, this one's, again, really nice. I think it's interesting that within the difficulty hard, they'll have a wide range of actual difficulties of problems. Like some of them are much simpler than others, even though they're both considered or classified as hard. So in this case, we have our two equations are y equals 2x plus 1 and y equals ax minus 8. So for these to have no solution, we want them to be two parallel lines, because two parallel lines will never cross. The solution to a system of equations is the point where they intersect. So if there's two parallel lines, two different y-intercepts, they will never cross, they'll have no solutions. Now, for them to be parallel lines, we need their slopes to be the same. So m1 should be equal to m2, and that's what we're figuring out what a is to make that true. And then we also need their y-intercepts to be different. So b1 is not the same, it's not equal to b2. So that part they already gave us, because these are both in slope-intercept form already. They were really nice with that. And the b value is just what you're adding at the end. So we've got we've got b1 is equal to 1, and b2 is equal to negative 8. So b1 is already not equal to b2. That part checks out. Now for the other criterion, we need m1 to be equal to m2. So m1 is equal to 2. m2 is our a value, right? It's just the coefficient that you're multiplying x by. I think y equals mx plus b form, just that coefficient in front of x. So m2 is a. If we want m1 to be the same as m2 and m2 is a, then a needs to be 2, right? So a is equal to 2. You could also plug it in. You'll see that there are going to be two parallel lines. But this one, again, these ones are really straightforward. So I think part of the thing with hard, just make sure that you know when is it no solutions, two parallel lines. When is it infinitely many solutions, the same line graphed twice. And when is it one solution, it's just two lines with two different slopes. And from there, note that they're going to do a lot of no solution questions, or they could do a lot of no solution questions. And just make sure that you can recognize, okay, if I want it to be no solutions, then I need to make sure that the coefficients in front of the x, if they're written in slope-intercept form, are the same. The y-intercepts are different. Or again, they might give it to you in standard form, which I think is a little bit trickier. Then you can just move it to slope-intercept form or do negative a over b. So we have two equations. We have 8x plus 7y equals 9, and we have 24x plus 21y equals 27. It says for each real number r, and the r's are not appearing in either of these equations, but they are in the solutions, which of the following points lies on the graph of each equation in the xy plane for the given system? So, that's already definitely making me think they're going to be the same equation. And if we look at the two equations, they are, right? If you multiply 8x by 3, you get 24x. 7y times 3 is 21y, and 9 times 3 is 27. So these are the same equation, just right, they're multiplying the left and the right side by 3, but if you graph them, they will appear exactly the same. They're the same line. So essentially, they're asking which of these points that use r and the x and the y value would be on, like just, you could say one of these lines, because if it's on one of the lines, they're on both of them. And again, This is something that some kids will mess up when they say there are infinitely many solutions. They think that that means any numbers will work. Oh, there's infinite solutions, any number will work. What infinitely many means, any value of x will have a solution. Well, not necessarily. I guess if you had vertical lines, which these are not vertical lines, but if you had two vertical lines, those still have infinitely many solutions, but they're not infinite values of x. But basically, it's just saying that any point on the line, and any line extends infinitely. That's the definition of a line. It goes on forever in both directions. If it only went one direction, it'd be a ray. If it didn't go on forever, it'd be a segment. But there are infinite points on here. And even if you narrowed it down to a segment, you could find infinite points within that small segment because you just go smaller and smaller intervals between them. But regardless of the point, there are infinite solutions, but it doesn't mean that every single pair of x and y is an answer. Actually, most pairs of x and y will not work, but it's just the specific ones that are on this line, any of those infinite solutions will be a solution for both. Don't get thrown off by that. I think some students would have seen this, like, well, aren't there infinite solutions? So couldn't technically anything work? No, it's not anything. Infinite does not mean everything. It just means that it's boundless, right? It goes on forever if you counted them. So I'm kind of hoping it's going to be A. I haven't looked at this yet. But if you plug in R, and the reason for that is that they have the x value is just R. But what we're going to do is just choose one of these equations. I'll probably choose this one I underlined in blue, just because the numbers are a little bit smaller. Again, they are the same equation, just written in two different ways. So 8x plus 7y equals 9. One way you could do this is just plug in these values. So plug in the x value and then solve for y and see if you get what's on the other side. So the first one, if it does work, is nice because it's just r, right? So we get 8 times r plus 7y equals 9. Now we want to get y. And actually what might make this easier is to get y alone, right? So we could, from the initial equation, get y alone, but that's essentially what we're doing here because r is in place of the x. All right, so I'm going to subtract 8r from both sides, and that gives me that 7y equals negative 8r plus 9, and then that's 7y, we want just y, so divide everything by 7. So we get y equals negative 8/7 r plus 9/7. Right, and if you want to write this original equation in slope-intercept form, it would be the same thing except x in place of r. So it would be y equals negative 8/7 x plus 9/7, like that. And just looking at it, that's what the y value should be. Negative 8/7 r, 8r over 7 plus 9/7. So without doing any more math, I already know it's going to be A. Now we could go through all of those other ones, right? If you plug in, I guess for this one you could plug in r for y, but you're not going to get the same thing. Right? It would be different. Or if you wanted to check C, you would plug in this entire thing for the x value. See if you get this as your output for y. Same thing here, but only one of them should work. In every other problem, I would check B, C, and D. And if you really want to make sure you get 100% correct, you can do that. But if you get gifted with this thing where A happens to be the right answer on something that's this tedious, on the real test, I would probably move on. Maybe you could put a star and say, I didn't check this one. So if you have time at the end, come back and check it. But I don't know. It worked out perfectly. Usually with these, they'll make C or D the answer just to make you do a bunch of them. But here we're lucky. Store A sells raspberries for $5.50 per pint and blackberries for $3 per pint. That's store A. Store B sells raspberries for $6.50 per pint and blackberries for $8 per pint. A certain purchase of raspberries and blackberries would cost $37 at store A, and it would cost $66 at store B, or $66 at store B. How many pints of blackberries are in this purchase? All right, so we're just going to write out these equations, and we could say R are the pints of raspberries, and B are the pints of blackberries, right? Because you're getting the same amount of each berry, whether you get it at store A or store B. It's just going to be a different cost. All right, so for store A, the cost would be $5.50 times R plus $3, or you just write 3, times B, or 3B. That's going to be equal to your cost. And we know that the cost is $37 if it's store A. For store B, it would be $6.50 times the number of pints of raspberries, so $6.50 times R, plus $8 per pint for blackberries, so 8 times B. You're really getting scammed at store B. And that would be $66 is the total. All right, so those are your two equations. Now we're trying to find how many pints of blackberries. So we're just trying to figure out what's B. So now after you've set it up, like really for the hard questions, when they give it like this, they give you a word problem. They don't tell you what the different, like they don't assign variables. You have to make your own variables. The hardest thing is supposed to be setting it up. Once you've set it up, then they're assuming that you know how to do elimination or substitution or the graphical method. In this case, like neither of them is jumping out as elimination being particularly easy. It's still probably going to be easier than substitution, but you're going to have to multiply both of them by something, or you have to multiply like the top equation by 8/3 to get rid of the b's, or we're trying to solve for b, so we're trying to get rid of the r. It would just be a bit tedious. This is definitely one where, again, I generally prefer to do it the algebraic method, but this is one where if you have the calculator, might as well use it. So I'm just going to type in the equations. So I'm writing them down now. If I go over here to Desmos, just type in the equations. We had 550r, which I'm going to write on my note. R becomes x, and that means that b becomes y. Again, b is what we're solving for, so we're ultimately going to try and find the y value of the intersection point. All right, but 550x plus $3, so you could just write 3y or 300y, it doesn't change anything, but I'm just going to type it exactly how it was, is equal to 37.00. And you can just write that as 37, doesn't really matter. And then for the second equation, we get 650 times r, which we're typing as x, plus 8 times y, or 8.00 times y. Again, the 0.00 is unnecessary. I'm just typing it, to show if you type it, it doesn't change anything, right? It doesn't make it more accurate or anything. But that would be equal to 66. Again, if I type in the 0.00, you'll see the line doesn't move because it didn't change the value. But now if we look at this, it's 4, 5. And again, x was what we put in place of the r, and y was what we put in place of the b. So if I write that solution out, again, make sure you note which one was x, which one is y, so you don't mess it up. R, b was 4, 5. That's the point that will satisfy both equations. And if you wanted to check it, you could even then, like that's another thing. I often say use Desmos to check your answer after doing it algebraically. You can also do an algebraic check to make sure that you typed it into Desmos correctly, right? So you could do 550 times 4 plus 3 times 5, and it will give you 37, right? That will check out the first equation. 650 times 4 plus 8 times 5 equals 66. So that will check the second equation, right? So it should be a pair, an ordered pair of r, b that will work for both equations and make it true. So that's one thing you do. Again, we're looking for what's the value of b. B is the number of pints of blackberries. We said that was 5. Okay, so it should be 5 pints of blackberries. All right, here we have another system of equations. 7/8y minus 5/8x equals 4/7 minus 7/8y is the first equation. The second equation is 5/4 x plus 7/4 equals py plus 15/4. In the given system of equations, p is a constant. So here's your p here. It's a constant. If the system has no solution, they really love doing these no solution ones. So the system has no solution, what's the value of p? Again, we're just trying to figure out what value of p will make it be 2 parallel lines. This one is parallel to this one. Now, you can think of that as they have the same slope, or if you put it into standard form, that the left side can be made to be the same, and when it's the same, the right side is different. And the right side being only the constants, the left side being all the variables added up, or the 2 variables added up. So this one, I'll do it the standard form way. I think that's easier for this setup here. So first we have 7/8y minus 5/8x equals 4/7 minus 7/8y. And now to get all of the variables on the left side, I'm going to add 7/8 to both sides, 7/8y to both sides. Note, if you do the thing where you find the slope doing negative a over b, that is assuming that you have the x terms before the y terms. So it would have to be negative 5/8x. Negative 5/8 would be your a value. So just be careful they put the y here first. I think they do that sometimes to trip you up. They might have just done that because it's negative and it just looks a little bit like neater to not have to write negative 5/8. You could do minus 5/8, but whatever. Or 7/8y plus 7/8y would be 14/8y, which you could then simplify to 7/4. But then you could simplify to 7/4, or you could do, right, you're doubling it, right? You're adding it to itself. So double this times 2. If you double something, you could also just divide the denominator by 2. Because you're dividing by a 2 times smaller number, so you're leaving twice as much. So you can think of it that way, but whatever you do, you'll end up with 7/4 y. And I'm going to just move that x term up front. I'm not going to even do it that way, so it doesn't really matter, but just so it lines up better with the other equation. All right, so we get negative 5/8x plus 7/4 y equals 4/7, right? So that's the first equation, just rewritten. And the second equation, here we have to get the py over onto the left side, and we also have to get rid of that positive 7/4 on the left side. So if I write it out, we have 5/4 x plus 7/4 constant equals py plus 15/4. And now to get this in the form I want, I'm going to subtract py from both sides. And I'm also going to subtract 7/4 from both sides. And that will leave me with 5 fourths x minus py is equal to, like here they cancel, here they cancel. That would be 15 fourths minus 7 fourths is 8 fourths. They have the same denominator, you just subtract the numerators. So now we have it set up like this. And again, for them to be two parallel lines, so two lines with the same slope, different y-intercepts, that's how you get no solutions, right? No solutions is what we're looking for, then the right side should be different. So don't worry about, oh, this is 4 sevenths, 8 fourths, those are like, that would be an ugly number if to change it to make them the same. We don't want them to be the same. So the fact that they are very different is a good sign for us. Now we want the left sides to be identical. And if we look at them, I think maybe that's why they put the y first, to try to trip you up that, right, if you're trying to make them identical, if you're doing it the same way I'm doing it, then you might miss that and just make, oh, the first coefficient should be negative something. Or the first coefficient should be 7 fourths, this one's 5 fourths. Right, just make sure you have your x's, your y's lined up. All right, so this is positive 5 fourths, this is negative 5 eighths. So you can multiply either of them by something, like you multiply this second equation by negative 1/2, and then that would make it into negative 5 eighths. But since I want the p alone over here, right, this already has the p alone, I'm just gonna multiply this first equation by negative 2, because negative times a negative will make it positive. And also 5 eighths times 2 would be 5 fourths. If you double something, that's the same thing as dividing the denominator by 2, because you're then dividing by a 2 times smaller number. So if we multiply it by negative 2, you have to multiply every term on the left and the right by negative 2. And that gives us, right here, the negatives cancel. It would be, you could say it's 10 eighths, which is the same as 5 fourths x. Right, so that matches. Minus, right, the plus 7 fourths times negative 2 would be minus, you could write it as 14 fourths, but then that simplifies to 7 halves y. Okay, again, you could do the thing where you do the denominator, divide it by 2. And then we have negative 8 sevenths over here. And that doesn't really matter as long as it's different from 8 fourths. So you're good. Okay, so here are our two equations. We have 5 fourths x on both, minus 7 halves y equals negative 8 sevenths. On the second one, we still have that 5 fourths x, and it's minus py. So if we want that left side to be exactly the same, then we know that negative 7 halves has to be equal to negative p, right? Both of that, or the coefficient in front of the y value would be your b value if it's in standard form, which it is. So then, to get p alone, you just multiply both of them by negative 1 or divide them both by negative 1. Just think negative what is equal to negative what, right? Those two things have to be equal to each other. So p is equal to 7 halves. That would be your answer. Right, that would be how you get no solution. Or they already have the two c values as different values. So c over b will be two different values, right? Which is two different y-intercepts. That's good. All right, we have 4x minus 9y equals 9y plus 5. And we have hy equals 2 plus 4x. In the given system of equations, h is a constant. So here's your h. And it's going to be another no solution one, isn't it? If the system has no solution, what is the value of h? Okay, really make sure you know how to do these no solution questions, because the fact that they have this many in the question bank, it could just mean that maybe people requested them because they kept messing them up or didn't know how to do them. But it likely means that that's going to be a common topic showing up, especially if you qualify to get the really hard questions by doing well in the first section. I think I did the last one in the standard form method where you want to get the left side to be identical, the right side to be different. We could do that again, but this time I think I will just do it the other way. I'll get it the slope-intercept form and make sure that your slopes are different, right? Just so you could show how to do both. I don't know that that's easier because of the first equation, but I just want to make sure that there's enough practice with both. I mean, in this whole video between the first part, which is part 12 of all the algebra questions, and this part, in the two hard systems videos that I've made, probably there will be enough of these that you can get a good idea of how to do either method. But I think this one, it's about the same for both. So I'm going to subtract 9y from both sides to get our y's all over here. I'm going to subtract 4x from both sides to get our y's alone. So we get negative 18y equals, this cancels, negative 4x plus 5. And now I just need to divide everything by negative 18. Look at that. Negatives cancel, 18s cancel. So we get y equals, and then 4 and 18 are both even, so this become 2/9. Okay, so we get y equals positive 2/9 x plus, or actually it's going to be minus 5 over 18, which those are relatively prime. All right, so that's your first equation, this one that I underlined in blue. And now for the other equation, if you want to get it into slope-intercept form, we have hy equals 2 plus 4x. So I'm just going to do the commutative property of addition, switch the order of those. So this will be hy equals 4x plus 2. It doesn't matter, but it just might help people if they're used to it being y equals mx plus b to quickly figure out what the slope and the y-intercept are. And now to get the y alone, I'm just going to divide both sides by h, this constant. And that would mean that y is equal to 4 over h plus, or 4 over h times x plus 2 over h. All right, so for them to be parallel lines, which if they have no solution, then they're going to be two parallel lines, two lines that never cross, so they have no intersection points, no solution. That means that they have to have the same slope. So that would mean the slope of this one is 2/9. So 2/9 has to be equal to the slope of the second one is 4 over h. All right, now, a couple ways you could do this. You could cross multiply and solve for h. You could go, okay, what do you have to multiply 2 by to get 4? You have to multiply 9 by the same thing. Just think, all right, what fraction with the numerator 4 is equivalent to 2/9? It'd be 4 over 18. So any of those ways, you'll end up with h is equal to 18. Because 4/18 is equal to 2/9, right? Just, you can multiply both of them by 2. And that also means that the y-intercept of this first equation, so negative 5 over 18, has to be not equal to the y-intercept of the other one. So not equal to 2 over h. If h is 18, negative 5 over 18 is not equal to 2 over 18. Those are the same denominator, but one of them is negative, one's positive, and they're two different numerators, like even absolute value. So those are completely different y-intercepts. That means that they will cross the y-axis at different points, even though they have the same slope. So two parallel lines, they're never going to cross. Again, they're asking for what's the value of h. We found h has to be 18. And you could plug that back in. Just type it in as 18y equals 2 plus 4x. When you graph it, you'll see, even on Desmos or on a normal calculator, those are two parallel lines. All right, a piece of wire with a length of 32 inches is cut into two parts. One part has a length of x inches, and the other part has a length of y inches. The value of x is 4 more than 3 times the value of y. What is the value of x? All right, so first of all, we know that the entire thing is 32 inches. So the entire length adds up to 32, and that's made up of x, and it's made up of y. So we can add x plus y, and it should add up to 32. All right, so there's one equation. Now we have this one that's comparing x and y. It says x is 4. So x is, think of is as is equal to. X is 4 more, so 4 more than 3 times the value of y. 3 times the value of y, you just write that as 3y. All right, so 3y plus 4. You could have written 4 plus this, but 4 more than, I think of it that way, because if they said 4 less than, you'd be subtracting 4 from whatever it was. Okay, so here are our two equations, and we're trying to evaluate what x is. Okay, so if you want to find x and you want to get rid of y. Now we could do substitution, elimination. You could do it graphically. Just type these both into Desmos and see what the x value is of the point where they cross. And I'll probably show that afterward. But what I'm going to do here is just do substitution. So I'll start by getting this y alone in this equation by subtracting x from both sides. We get that y is equal to 32 minus x. You could also write negative x plus 32. But now I will substitute this in for y in the second equation. So we get that x is equal to 3 times, instead of y, it'll be times this equivalent value of y, 32 minus x, and putting it in parentheses, so the entire thing is multiplied by 3, not just the 32, not just the negative x. And then we still have the plus 4 at the end. So now if I distribute this 3 to the 32 and to the negative x, it gives us 96 minus 3x plus 4 is equal to x. And now 96 plus 4 is 100. And I'm going to get all my x's on the left side. So I'll add 3x to both sides, like that. And x plus 3x is 4x, negative 3x plus 3x is 0. And then 96 plus 4 is 100. So 4 times x is 100. You can think what times 4 is 100 would be 25. Or just the opposite of times 4 is divide by 4, divide both sides by 4. We get that x equals 25. So 25 should be our answer. Now to check that, to verify it's correct, you can figure out what y is. So plug that 25 in for x here. Get 25 plus y equals 32. Subtract 25 from both sides, you get that y is equal to 7. Or you think what plus 25 is 32, so 7. And then we can check it in the other equation. So this equation here, by plugging in, so our order pair would be 25 comma 7, right? X comma y. So if we plug that into the second equation, it would be 25 equals 3 times 7 plus 4. 3 times 7 is 21. So 21 plus 4 is, in fact, 25. So that checks out, right? The value of x, if you plug it in to find y with one equation and then use that ordered pair xy in the other equation, it does work. So that's one way to check it. We could also, if we write down these equations, we have x plus y equals 32. and x equals 3y plus 4. Again, we're trying to find the value of x, which we found to be 25. If I come here to Desmos and type in the two equations, x plus y equals 32, and x equals 3y plus 4. We'll graph them both. You have to zoom out so you can see them. And here's the point 25, 7. So that's the same order pair we found. The x value is 25. This way it might actually be faster than doing substitution. Depending on how quickly and confidently you can type into Desmos, this might be the best or the fastest way to do it once you write out those equations. That's fine, or you can use it to check. All right, here we have one of two equations in a linear system is 2x plus 6y equals 10. So here's one of the equations. The system has no solution. Another no solution question, which means it's going to be two parallel lines. Which of the following could be the other equation in the system? All right, so for there to be no solution, we know it's two parallel lines, which means they have the same slope to different y-intercepts. If you write it out in standard form, it should look like ax plus by equals c. It should basically have the same a and b values or be able to be multiplied by something to make it so it has the same a and b values as this 2x plus 6y. But when it has those same a and b values, it should have a different c value. So essentially, we've got 2x plus 6y. If we do like the ratio of a to b, it should be a 1 to 3 ratio. So a to b should be a 1 to 3 ratio, not 1 to negative 3. They have to actually be the same sign. They could be both negative. And if that's the case, then like think about what you'd have to multiply it by or divide it by to get it to be 2x plus 6y, the c should be different. All right, so that's just one way you could do it. You could also get all of them into slope-intercept form, compare their slopes, compare their y-intercepts, but let's see. So x plus 3y, that is that 1 to 3 ratio, equals 5. Now, if we want it to be the same form as this, 2x plus 6y, we'd have to multiply everything by 2. So times 2, times 2, times 2, that gives us 2x plus 6y equals 10. That's identical, right? Even the c value is the same, which means these are the same line. If you type in both of these equations, you could also do that to check. Type them both into Desmos, it will just graph the same line twice. So that would be infinite solutions, not zero solutions. So it's not that one. X plus 3y, we have that again, so that's good, equals negative 20. Well, we already know if it's x plus 3y for it to be the same line, this has to be 5. And right, x plus 3y, if you multiply it by 2, it would give you that 2x plus 6y. So it looks like B is going to be our answer, but just to verify, times 2 times 2 times 2 gives us 2x plus 6y, so that left side matches, equals 2 times negative 20 is negative 40. That's not the same as 10, so that's good. All right, so it will be B. I'm going to rule out C and D as well, just to be safe. So here we have 6x minus 2y. That's a 3 to negative 1 ratio. We want a positive 1 to positive 3 ratio. Right, so it's the same. There's nothing you can multiply this left side by to get the same left side over here. So these are going to have two different slopes. You could also think of it if you do like the slope of a line in standard form is negative a over b. So for the first one, it's negative 2 over 6, which equals negative 1/3. Right, so that's the slope that we want it to be the same as. Right, if the two parallel lines would be the same slope. This one, negative a is negative 6 over b is negative 2. So it's negative 6 over negative 2. The negatives cancel. 6 over 2 is 3. So these are actually perpendicular slopes. This line would be perpendicular to it. But it doesn't matter if two lines are crossing at a 90-degree angle or at like a 1 and a 179-degree angle. If they intersect at any point, then there's one solution. So this is one solution. We want the one with 0 solutions, which was B. And same thing with D. Let's say the slope here would be negative A over B. That would be negative 6 over 2, which equals a negative 3. So, I mean, that's negative, like the slope that we want, but it's going at a steeper rate. So if the line that we have is going down 1 over 3, down 1 over 3, this one is going down 3 over 1, down 3 over 1. So they will cross at some point. Okay, any two lines with two different slopes will cross at one point. So this one also meets at one point. It's not that, it's B. All right, we have a system of equations here. It's a little bit confusing where one ends and the other starts. It appears to be after this 117. Now, hopefully, again, on the real test, they will do a better job separating those. The first equation is the quantity, so parentheses, x minus 2 and quantity, minus 4 times the quantity, y plus 7 and quantity, equals 117. The second equation, we have the quantity x minus 2 plus 4 times the quantity y plus 7 and quantity equals 442. The solution to the given system of equations is x comma y. What is the value of 6 times, open parentheses, x minus 2 and parentheses? All right, so whenever they ask for something like this, where they're not actually asking for x, they're asking for x plus something, x minus something, x times something. In this case, we've got, you could say it's the same as 6x minus 12, but it's 6 times something subtracted from x. That tells you that there's probably a shortcut to do it. And since they have x minus 2 in the equation, and x minus 2 is part of what we're going to be solving for, what I like to do is make another variable. So maybe I'll say a is equal to x minus 2. And you can even put in parentheses so it matches better. And now if I rewrite these two equations, instead of x minus 2 minus 4 times y plus 7, actually, since they have y plus 7 in both, why don't we make b into y plus 7? It doesn't really matter, but it just simplifies the question a little bit. So now we'll have a minus 4b equals 117 for the first equation. And then for the second equation, we have another x minus 2. That will be a. And we'll actually, let me write it underneath the other one. We have a, and then it will be plus 4b equals 442. Right? That's our second equation. And I just put an a in place of the x minus 2, and I put b in place of the y plus 7. So now if we look at it like that, it's already lined up for elimination to eliminate the b, so we could solve for a. And a has the x minus 2, which is what we want as part of our answer. Again, we want 6 times that x minus 2. So like we can even write like 6a is what we want. All right, so now if we combine these two, add the left side of the equation to the left side, add the right side to the right side. Since they're equal on both sides, we're adding the same thing to both sides, or an equivalent value. So a plus a gives us 2a. Negative 4b plus 4b is 0. Those cancel out. And then 117 plus 442 will give us 559. So 2 times a equals 559. And now from here, you could go, okay, I need to find a. I'm going to divide both sides by 2. But remember, we're trying to find 6a, not 1a. So since we already have 2a, and this is an odd number too, so it would give us a decimal. Not that it's a super hard decimal to do. But what do we have to do to 2a to get it to be 6a? Just multiply it by 3. If you multiply the left side of the equation by 3, you got to multiply the right side by 3. So 3 times 2a gives us 6a. Again, that's what we want. Is equal to, let's see, that would be 1500 plus 3 times 60 is 180, and then we're subtracting 3 because it was not 60, it was 59. So that would be 1677. Let me just check that on the calculator to be safe. 559 times 3 is 1677. All right, so this is our answer. And just to verify, again, we can plug in what a is. A is x minus 2. So this is 6 times a, so 6 times x minus 2, again, is equal to 1677. That's what we want for our answer. So our answer will be 1677. All right, we have equation 2x plus 3y equals 7. And we have this equation 10x plus 15y equals 35. For each real number r, which of the following points lies on the graph of each equation in the xy plane of the given system? So we have the same question essentially. I asked the same thing with different equations. But the last time, the two equations were the same. And that makes me think that whenever they ask this question, it probably will be two like equivalent equations. Just essentially, you have to multiply every term by something to make them look the same. So in this case, 2x, to make it into 10x, you have to multiply it by 5. So let's multiply the entire thing by 5. So every term on the left, every term on the right. 5 times 2x is 10x. 5 times 3y is 15y. 7 times 5 is 35. Right, so these are going to look the exact same. If you graph these both on Desmos, they will just be the same line graphed twice on top of each other. So this has infinitely many solutions, but they're not asking how many solutions does it have. That would probably be in the medium section. Instead, what they're asking is like which of these options, so we've got all these things with forms of r and the x and the y value. This one has r as the y value. These two have r as the x value. They're asking which of those would work for each of the equations. It means basically which would work for one of the equations because they're the same equation. If it works for one, it will work for the other. Let's see, it's got a slope of negative 2/3. Its y-intercept is 7/3. So it'd be something, 1, 2, a little bit above 2 as the y-axis, is the y-intercept, like 2 1/3. And then it's going down to over 3, down to over 3. So it looks something like that, right? You're just graphing it twice. So there's one of them, and you graph it on top of itself. So they want to figure out which of these options that includes r would work for all of these. All right, so I'm just going to take one of the equations. Again, they are the exact same equation, just multiplying everything by 5. So I'll take the first one where it doesn't have the bigger numbers. Right, so 2x plus 3y equals 7. And let's see, looks like 2 of them plug in an x, 1 of them plugs in a y. So what we can do is get this into slope-intercept form. So I'll subtract 2x from both sides. That gives me 3y is equal to negative 2x plus 7. and then divide everything by 3, you get y equals negative 2/3 x plus 7/3. Okay, so this is the same as both of those equations. All right, so now I just take this equation and I can just plug in r in place of x. For c and d, you can do that. So I'll just put in r right there and then see which it matches, because the y value should be equal to negative 2/3 r plus 7/3. Well, this one's positive 2/3 r plus 7/3. So it's not that one because it's, again, that should be negative. And then this one is negative 3/2. That's the reciprocal. They flipped the 2 and the 3, and it's plus 7/2 instead of 7/3. So it's not c or d. All right, so essentially this y equals form, the y equals mx plus b will not really help us here. What we can do is, now I could get it so I have the x alone. I mean, I could also just plug in this, these longer expressions for x. And, maybe I'll do that for a. So we'll say y is equal to negative 2/3 times, instead of x, it's going to be r over 5 plus 7, and then plus 7/3. Okay, so now if I distribute this negative 2/3 to both of the terms that are in the parentheses here, this value of x that I plugged in from a, it would give me y is equal to, let's see, that's negative 2r over 15, and then negative 2/3 times positive 7 would be negative 14 over 3, and we have plus 7/3. So negative 14 over 3 plus 7 over 3 would give us negative 7 over 3. So y would be equal to negative 2/15 r minus 7/3. And that's not the y value they have here. They have negative r over 5 plus 35, which is not equivalent. So actually, we can eliminate a, and that means it's going to be b. But just to verify that, we could plug that in. So plug in this long expression and get r, or we could even get the x alone. So we could say minus 3y on both sides. We get 2x equals negative 3y plus 7, and then divide everything by 2. We get that x is equal to negative 3/2 y plus 7/2. And now if I plug in r in place of the y, right now it's the y value, then the x value should be negative 3/2 times r plus 7/2, which is what they have here. So negative 3 over 2r, or negative 3r over 2 plus 7/2. All right, so that does match. B will be your answer. And again, I guess I'll just show, since we already have it here, since if you did want to use just that y value, it would give you the same thing. So you'd say y equals negative 2/3, and instead of x, we'd be plugging in this x value, which is, parentheses, negative 3r over 2 plus 7/2. And then you still have to finish it off, which was plus 7/3 is the y-intercept. And now you just simplify that, and it should give you r, which was the corresponding y value for that. All right, so this, I'm just showing this is a little bit more work than what we did up here, but it might be a little bit more satisfying to complete. So let's start by distributing this negative 2/3 to both of these terms in the parentheses. Negative 2/3 times negative 3/2, the negatives will cancel. Negative times the negative is positive. And then 2/3 times 3/2, that's multiplying it by its reciprocal. It makes 1, so that will just become 1r. So y equals r. And then negative 2/3 times 7/2, positive 7/2, will be negative, the 2's will cancel, and then it will just be negative 7/3. So we'd get r minus 7/3, and then we still have this plus 7/3 outside the parentheses. Negative 7/3 plus 7/3 will add up to 0, so y would be equal to r. So that really didn't take that many more steps than what we're doing up here. Looks like, the distribution takes a little bit longer than just plugging in the value. But yeah, we get the y value would be r if this is your x value, so that would be further confirmation that B is the correct answer. All right, it says y equals 6x plus 18. One of the equations in the system of two linear equations is given. The system has no solution. Another no solution one. Which equation could be the second equation in this system? Okay, it's in slope-intercept form, although the options down here are not in slope-intercept form. They're in standard form. Now, what we could do is convert this original one into standard form. So you could make it subtract 6x from both sides. That gives you negative 6x plus y equals 18. All right, so this is equivalent to the equation they gave us. And then we could use that to compare, right? So we could look at it. We want to have the left side be the same, or something that could be made to be the same, and the right side to be different, because that indicates if this side is the same, that indicates the slope's the same. But when this side is the same, if they have a different constant on the right side, that tells you that the y-intercept is different, right? Because the slope of a line written in standard form would be negative a over b. So for this original line, that's negative 6, so it ends up being positive 6, over 1y, right? So over 1, that's negative 6 is 6. 6 over 1 is 6. Right, so the slope we want to be 6. The y-intercept is c over b, and I'll just write y-int. A lot of times you use b for the y-intercept, but when you're doing standard form, that gets confusing because there's another b that's not the y-intercept. But the b, again, was 1. So c over b is 18 over 1. So for this one, our y-intercept is 18. So we want the y-intercept to not be 18 because two parallel lines will have the same slope. So you could say m1 equals m2. Right? The slope of the first line is the same as the slope of the second line, but the y-intercepts should be different. So just with that in mind, we could say, okay, well, we've got negative 6x plus y, that matches what we had, equals 18. Oh, that matches exactly. So this one would have infinite solutions. It's the same line, so it's not going to be the one with no solutions. Then we have negative 6x plus y equals 22. That's a different c-value, so it will be that. That one will have a y-intercept of 22 with the same slope of 6. Now for these ones, we got the a value is negative 12. The b value is still 1. So for this, if you did the slope, it'd be negative 12 over 1, which equals 12. That's a different slope, right? Our line has a slope of 6. This line has a slope of 12. This one is the same thing, but also have a slope of 12. So they have different slopes, which means they'll have one solution, infinite solutions. Option B is the only one that has 0 solutions. So that's the right answer. Here we have a graph. It's a graph of two lines on a coordinate axes. You can see that they cross at this point here, which is 8 over and 2 up. It looks like one of the lines is just a horizontal line. So that's at y equals 2. So every point on here has a y value of 2. That's why the point of intersection also has a y value of 2. And then the other line has, looks like a y-intercept of 4. So it's at 0, 4. And it's going down 2 over 8, which is same as down 1 over 4, down 1 over 4. So our slope would be negative 1/4. So it's negative 1/4 x plus 4 for that line. And this one is y equals 2. So let me bring these down. And now let's read the question. It says, if a new graph of 3 linear equations is created using the system of equations shown and the equation x plus 4y equals negative 16, how many solutions x comma y will the resulting system of 3 equations have? So for a system of 3 equations to have a solution, it has to be a point that is on all 3 equations, right? It's not just meaning that it's like where do 2 of them intersect. All 3 of them would need to intersect. So right off the bat, the fact that these two only intersect at this one point, 8, 2, tells us that either this other line is going to cross through there and that's the one point where they all 3 intersect, or if this new line, this x plus 4y equals negative 16 doesn't pass through there, then there are 0 solutions. Right? So it's either exactly 1 or 0. So we can cross off C and D immediately. Because even if this line was the same as one of the other two, it doesn't matter. It has to be a point where all 3 of the lines touch. Right? For a solution for the system means it's a solution for every single equation in that system. So I'm just going to rewrite this in slope-intercept form. So it's a little bit easier to graph. We can see it visually. And then maybe we'll see if it matches one of the other equations. So we'll start by subtracting x from both sides. That gives us that 4y is equal to negative x minus 16. And then we can divide everything by 4. Right, to get the y alone. And it's y equals negative 1/4 x minus 4. So just looking at that, that's going to be parallel to the purple line, which indicates to us it's never going to cross that one. So even without graphing it, I know it's going to be 0, right, if you have a parallel line. But let's see. So this one's down at negative 4. It's the same thing. Down 1 over 4, down 1 over 4. You could go up 1 to the left 4, up 1 to the left 4, like that. So it actually will cross that blue line, right? It's going to cross that blue line somewhere that's off the screen, somewhere over there. That's one point of intersection. It's never going to cross the purple line, but even if it crossed both lines, it wouldn't matter. As long as it doesn't pass through this point where the 2 other lines intersect, then there are 0 solutions. And here we have a system. Again, it's not well delineated where this one ends and the other one starts, but I think it's going to be here. So it looks like the first equation is 5y equals 10x plus 11. The second equation is negative 5y equals 5x minus 21. The solution to the given system of equations is x comma y. What is the value of 30x? Okay, so we want to find 30x, which means that we could solve the equation for x. And it looks like the way it's written, you could already do elimination. Usually when we're doing elimination, you'll have like the x and the y on the same side, and you can eliminate one of them that way. But if I just rewrite these, like one on top of the other, we have 5y equals 10x plus 11. And then we have negative 5y equals 5x minus 21. If I add the left side to the left side, the right side and the right side. 5y plus negative 5y is 0. 10x plus 5x is 15x. And then positive 11 plus negative 21 would be negative 10. So we get 0 equals 15x minus 10, which means that 15x and 10 are the same, or we could just add 10 to both sides. We get 10 equals 15x. From there, you could go, all right, well, if I want to find x, I'll divide both sides by 15. But remember, we're not looking for x, we're looking for 30x. So we just go, what do you have to do to 15x to get 30x? You have to double it, so double both sides. Whatever you do to one side, you have to do the other side. 10 times 2 will be 20. So that means that 30x is equal to 20, which will be our answer. And that's the last question. All right. The systems of equations, there aren't that many different things they would ask. There were a lot of questions that had to do with what would the coefficients have to be to make it no solutions, or which of these equations would give you no solutions. So just make sure that you really understand how to identify if two lines are parallel or not, or what a coefficient or constant would have to be to make it so that the two lines would be parallel. And it just comes down to, understanding how you could do that in standard form, how you could do that in slope-intercept form, how to use Desmos to verify your answers. They had a couple like this where, right, they give you two lines that are the same, except, again, they're multiplying every term by the same thing. It would still graph as the same line. And then they're asking which set of points, which aren't actual point values, but they're giving you it in terms of a variable or a constant, would be true for every point on that graph. So I went over those to make sure that you understand how to do them, because if they had a couple examples of it, then it's probably something that will come up. This was a trick. I did a lot more of these in some of the other videos, some of the maybe the medium difficulty ones for systems, and then some that were just like linear equations, where you set another variable equal to like x minus 2 or x or y minus 7. It just simplifies the math a little bit. You don't need to do that. You could have also done the distributive property. It would just take longer. So, I think if they're not even really shortcuts. Shortcuts kind of has a connotation of like you're cheating in some way, but this is just, I think this is what they want you to do. That's why they ask for this. But just know, if you don't feel comfortable doing that, you can do it another way. Or if you want, you could even graph these on Desmos, find what x and y are, and then just plug it in. But I think this is a little bit faster way, more efficient way to do it. And yeah, I'm trying to think what else came up a lot. This is another one that is no solution. So really the no solution ones are what came up the most, at least in this part of the video, just being comfortable with these constants. A lot of them you have to maybe write your own system of equations from a word problem in context, and then you have to solve it. Remember that once you write them, as long as you've written them well and you're confident in the way you wrote them, you could just plug it into Desmos. Just make sure you keep track of which variable you're putting as x, which variable you're putting as y. You could even just initially put them as x and y, just keep track of, what does x mean, what does y mean in this context. Like for this one, you're solving for the blackberries, know which variable is that. So which variable represents the number of pints of blackberries. These ones were pretty easy. It's another one with no solution, but when they write it in slope-intercept form, it should be pretty simple. I mean, not that the standard form ones are that complicated, but just it takes more steps in general. And yeah, those are all the ones that we went over in this part. Remember, I went over a lot of other hard difficulty systems of two linear equations and two variables questions in part 12. So if you were looking for a specific problem and you didn't find it in here, or a specific topic, make sure that you watch those as well. You can look through the video description to find those. But anyway, hopefully you found this video helpful. If it's something that you thought was useful and that you'd like to see more of, make sure that you like and subscribe. That will promote more videos like this in your feed, videos from me, other creators that are doing SAT and math content. And besides that, if you found any errors or you had any questions, anything was unclear, you want me to go over anything, leave that in the comments and I'll make sure to at least respond to it and potentially make another video addressing something that you might bring up. But besides that, best of luck with your preparation, and I hope to see you in the next video. Thanks.